Hi and welcome to this quick video about this probability question. Now this question is from exercise 7H of the IBAI textbook. It's not a particularly nice question. To solve it we're going to need to use some algebra. Now probably the easiest way to do it is to use a Venn diagram. So if I think about having my Venn diagram here, we need to consider the two options that we can have. We've got a blue car and we're thinking about the number of doors, and I'm going to say this is whether we have 5 doors or not. Now I don't know any of the individual probabilities, so I'm going to call them, or I'm just going to give them letters at the moment and set up some equations. So I know from here that x plus y must equal 0.5 because they're the probabilities contained within blue. It also tells me that the probability that the car has 5 doors is 0.3. So y plus z must equal 0.3. It then also goes on to tell me the probability that it's blue or has 5 doors is 0.6. So x plus y plus z must be 0.6 because they're the 3 parts that are giving me that probability of blue or 5 doors. And if we look at what the actual question is asking me to do here, find the probability that it's not blue or having 5 doors, that's going to be in this section outside of those because we have everything that's blue or and or with 5 doors in the circles. So we now have simultaneous equations with 3 unknowns, 3 equations. I can use my GDC, as we're allowed to certainly in this course, to find that x equals 0.3, that y equals 0.1 and z equals 0.2. So to find question mark, I just need to do 1 minus 0.3 minus 0.1 minus 0.2 to get 0.4. So really this was all about setting up a Venn diagram, or setting up a different diagram. You could use a tree diagram as well, but setting up a diagram that allows me to see the numbers, to see what's going on and start working out what bit goes where. So it all came down to, and saying this is why I think the Venn diagram is easier than the tree diagram, because it's easier to see where those numbers are going. But we'll look at it with a tree diagram as well, in case anyone does prefer a tree diagram. Now if we think about the original part of it, we know that I could have blue or not blue, so they're the 2 possible colours. And it tells me, or I know not 2 colours, but you know what I mean. It tells me the probability of getting a blue is 0.5, so by definition the probability of getting not blue is also 0.5. Now I'm interested in things with 5 doors. So I could have blue with 5 doors, and I could have blue not with 5 doors, I could have other with 5 doors, or I could have other with not 5 doors. And unfortunately it doesn't give me any individual probabilities with that. So at the moment I'm just going to need to give everything a letter. I'm going to call it X, Y, Z and question mark. So it tells me here that the probability that the car has 5 doors is 0.3. So if you think about how a tree diagram works, that's going to tell me that 0.5y plus 0.5 question mark, 0.5z equals 0.3. And I could simplify it now, I could factorise that if I wanted to, but there's no need to. Tells me here the probability that it's blue or has 5 doors is 0.6. So I know the probability that it's blue is 0.5, and I know the probability that it, so that's from here, the probability that it's blue is 0.5, and the probability of other coloured with a 5 door is 0.5z. That equals 0.6. So I now have 2 equations with 2 unknowns. Now it just so happens that in the second equation, the green equation, there aren't any y's, but again we can solve that, and that will tell me that z equals 0.2 and y equals 0.6. So I can put those on, 0.2 there and 0.6 there. Now, from the tree diagram, we can see that that must be 0.4 and that must be 0.8. So finally, to answer the question, the probability of me having a car that is not blue with 5 doors, so the probability of me having a car that's not blue or with 5 doors is 0.5 times 0.8, which is 0.4, so we get the same answer in just a different way. I hope that makes sense. Thanks very much.